Hi, this is Andrea Hendricks. Let's take a look at some problems from section 4.1 and 4.2 homework. You'll notice I have these combined because, as I talked about in the lecture video, there's only a few things that you need to know from this material. You don't need to know the whole extent of those two sections. So you just need to know about the 1 over x and the 1 over x squared and graphing those transformations. So pay particular attention if you're going to work problems from the textbook that you stay within these problems that are listed on the syllabus. Problems 1 through 18 and 19 through 38 from 4.1 and only 6 problems from section 4.2. So let's go over some of these problems from section 4.1 to begin with, just to make sure that you understand the basic concepts. What is the domain of 1 over x and what is its range? So the domain is basically all reals except for 0, right? That negative infinity to 0, union 0 to infinity, and the range was the same thing, right? That is the domain and the range, even though they mean different values, right? X values and Y values. What is the domain of f of x equals 1 over x squared, and what is its range? Well, the domain is negative infinity to 0, union 0 to infinity, but the range is only 0 to infinity, right? What is the interval over which f of x increases, decreases, or is constant? So that's bringing back in those things that we talked about. Well, remember that the basic shape of 1 over x looks like this, right? So where is it increasing or decreasing? Well, as you move from left to right, this piece is going down, and this piece is also going down. So it's actually decreasing on all of its domain. So we would say it's decreasing from negative infinity to 0, union 0 to infinity. Now what about 1 over x squared? 1 over x squared looks like this shape. So notice that it's increasing and then it's decreasing. So it's increasing from negative infinity to 0, but it's decreasing from 0 to infinity. Okay? Number 5 says, what is the equation of the vertical asymptote of the graph? Y equals 1 over x minus 3 plus 2, and of the horizontal asymptote. Well, remember the vertical asymptote is where the function is undefined. In other words, what makes the denominator 0? So here it would be undefined at the value of 3. So for part 5, our vertical asymptote would be at x equals 3. And the horizontal asymptote is actually whatever this outside changes, because it's shifting it up 2, so it's going from y equals 0 now up 2 units to be y is equal to 2. What is the equation of the vertical asymptote of the graph 1 over x plus 2 squared minus 4? So here again, for the vertical asymptote, we're trying to find what value of x makes the denominator 0, and that would be negative 2. And that should coincide with what we've learned about shiftings, right? It moves left 2 units, so the vertical asymptote is x equals negative 2. And the horizontal asymptote is whatever is this outside number, so that would be y is equal to negative 4. We talked about even or odd in the lecture video. 1 over x squared is an even function, and that's because it's symmetric with respect to the y-axis. And 1 over x is an odd function. It's symmetric with respect to the origin. Okay. Use the graphs of the rational functions in A through D to answer each question. We probably won't do all of these, but just to make sure you're understanding, it says in part 9, which choices have domain from negative infinity to 3, union 3 to infinity. So there we would expect to see a vertical asymptote at 3, so that's in part A, as well as part B, and also C. But part D has a vertical asymptote at 0. So that would be at A, B, and C. Which choice has a range of negative infinity to 3, union 3 to infinity. So the range would say now we want this to be a horizontal asymptote at 3, and that is part B only. Which choice has a range of negative infinity to 0, union 0 to infinity? So we would want the x-axis to be our asymptote, so that happens in part A. and that's all, right? Because the negative infinity to 0 would imply that it's down below the x-axis, and that's only in part A. Which ones have a range of 0 to infinity? Well, that would be only above the x-axis, and that would be for C and D. Okay? Part 19 through 22 says to explain how the graph can be obtained from 1 over x or 1 over x squared and draw a sketch by hand. Then you can do an accurate depiction of the graph on the graphing calculator, and then finally give the domain and range. So let's talk about how they're related. First of all, 2 over x is a vertical stretch, right, because it's just a multiple of 2. So it's a vertical stretch by a factor of 2. So that would not change the vertical or horizontal asymptotes. It just makes all the y values increase by a factor of 2. Negative 3 over x, so that's going to be a reflection and a stretch, right? The opposite of y is going to be a reflection across the x-axis. And then also a vertical stretch of 3. One over x plus 2 and 1 over x minus 3, those are both inside changes, so those we're going to move left 2 units and right 3 units. Okay? So here the asymptotes would be affecting, in fact, the vertical asymptote, not the horizontal asymptote. So let's just talk about how would you do a reflection and a vertical stretch. So if you remember 1 over x looks like this basic shape. Think about some key points through your transformation. Like this was a point 1, 1, and negative 1, negative 1. So if we're going to reflect that across the x-axis, it's going to flip over, right? So that's going to take the opposite of y, and then it's going to multiply y by 3. So let's think about how that would happen. If I'm taking the opposite of y, so that would make that 1 negative 1, and then stretch by a factor of 3 would make that 1 negative 3. So this piece is going to come down now like this. Negative 1 is going to flip over to become negative 1, 1, but stretch by a factor of 3 to be here. Okay? So that's the graph of number 29. And then looking further at how these relate to the original function, like 1 over x minus 2, that's going to move down 2 units. 1 over x plus 1 is going to move up 1. 1 over x minus 1 plus 1, now that's going to have a combination, right? That's going to move it right 1 and up 1. 2 over x plus 2 minus 1 is going to move left 2 and down 1. Right? 1 over x squared minus 2 just moves down 2, but that's the basic graph of 1 over x squared. So you have to think about which is the basic graph that you're moving. Are you moving 1 over x or 1 over x squared? So 27 through 34 are all variations of 1 over x squared. So let's just talk about one of these. Number 34 is probably the most difficult, where you have y is equal to negative 1 over x minus 4 squared plus 2. So what would happen here? So in this particular problem, you're going to do a reflection across the x-axis. You also have to move it right 4 and up 2. Okay? Now think about the original function. Looks like this. So we got to reflect it, move it right, and then move it up. So what are those key components that are going to be moving? So we need to think in particular about our asymptotes. So if we have an asymptote at 4, right, vertical asymptote at 4, because that's where it's undefined. And the horizontal asymptote is going to be at y is equal to 2. Now, what is going to be the basic shape? Well, remember it was all up, but we reflected it down, so now it's going to be down. And if you want to take the key points through the transformation, you certainly can. Like if we started with 1, 1, and it reflected down, that would become 1, negative 1. And then we had to move it right 4 to become 5, negative 1. And then up 2 would be 5, 1. So 1, 2, 3, 4, 5, 1. So this piece is going to look like this. And then the other piece, by symmetry, if you want to follow this point, negative 1, 1. To reflect is going to become negative 1, negative 1. And we got to move it right 4, so that would take it to 3, negative 1. And then up 2 would be 3, 2. Okay? I'm sorry, not 3, 2, 3, 1. We moved it up 2 here. So it's going to look like this. So what is the domain and range of this one? So the domain is negative infinity to wherever our vertical asymptote is, which is 4, union 4 to infinity. And our range is from bottom up, so that would be from negative infinity up to our vertical asymptote, which is 2. Okay? What about end behavior if you want to get into that? We know that as x is approaching plus or minus infinity, y is approaching our asymptote of 2. And as x is approaching 4 from the right and from the left, y is approaching negative infinity. Here's a concept check. It's giving us 4 ways that the graph of a rational function can approach the vertical line x is equal to 2. Identify the graph of each rational function. So we're going to have to do some matching here. So if you look at 1 over x minus 2 squared and negative 1 over x minus 2 squared, those are the same except for being reflected, right? So that moves the graph of 1 over x squared right 2 units. If it's not reflected, that's going to be c, right? If it is reflected, that's going to be d because it flips it over. And then 1 over x minus 2 just moves 1 over x to the right 2 units. And negative 1 over x minus 2 moves it right 2 units, but then also reflecting. So remember, 1 over x is traditionally down and then up. So the non-reflected graph is going to be a, right? And then the one that is reflected is going to be b. Okay. And these are problems from section 4.2 that I have brought in here. It says give the equations of any vertical, horizontal, or oblique asymptotes. Well, we're not talking about oblique asymptotes here. That's whenever the degree of the numerator is exactly one more than the denominator, but you don't have to worry about all that. Vertical asymptotes are where it's undefined, so that's going to be at x is equal to 5 and at x is equal to negative 9. And then these are just transformations of 1 over x, so the horizontal asymptote doesn't move when it's shifted right, so that's going to be y is equal to 0. Here it's shifted left 9 and reflected, but that still does not affect that horizontal asymptote. Okay. And then it says to sketch the graph of each function, your graph should include all asymptotes and be comprehensive, and you can use your graphing calculator as an aid. So you can certainly do that. Number 46, we'll just talk about briefly, and then I'll refer to this more on the graphing calculator video. The thing you have to be careful about here is to see how the change is occurring. So what you would need to do in that one, if you're going to do this by hand, is factor out the denominator. 2x plus 4 is the same thing as 2 times x plus 2. So you can really think about this as a negative 5 halves times whatever x plus 2 if you want to think of it that way, where you've got this stretch factor, reflection, and also shifting it left by 2 units. Okay, so that's going to take it left 2, reflect across the x, and then do a stretch by a factor of 5 halves. Okay. So if you wanted to look at that graphically, understand the vertical asymptote is going to be moved. It's going to be moved to -2. Our horizontal asymptote is not going to be moved because that doesn't change in any of those transformations, so it's still going to be y is equal to 0. It reflected, so instead of going down and up, it's going to become up and then down. So just to get the graph of the general shape, it's going to look like this. Now if you want to be more precise, you can. Since this one will cross the y-axis somewhere, we know that we could set that equal to, or rather plug in 0 for x and find out where the y-intercept is. So if you wanted to do that, the y-intercept would be at y is equal to -5 over 2 times 0 plus 4, which is at -5 over 4, or -1 1/4. So I didn't really draw this to scale. If I was going to do that better, I could do that. Let me put that in here better. So at -5/4 would be here, so it's going to look something like this graph. Okay? And the last thing we'll end with, the switch function has a graph that does not have a vertical asymptote. So does not have a vertical asymptote means that there's no values of x that make the denominator 0. So let's look at this. Is x squared plus 2 ever equal to 0? Well, that would mean that x squared has to be -2, but when we square a value of x, we only get a positive, not a negative. So that one actually would be the answer. Because x squared minus 2 is equal to 0 when x squared is equal to 2, or x is equal to plus or minus the square root of 2. So that has two vertical asymptotes. Part C, x squared is equal to 0 when x is 0. And then x minus 8 is equal to 0, of course, when x is equal to 8. So the only one that wouldn't have a vertical asymptote would be part A there. Okay, so I'm going to do a separate video for the homework problems in my math lab, and you can watch that if you want. Thanks.